Hello, my name is Cormac Matthews and this is part 2 of my CA2 assignment for Special Line Effect. In this video we'll be looking at the adaptive bloom as well as the glow bloom. So a description is that is to provide a bloom filter which the scene is downsized to 1/16 using two stage of bilinear and then average the luminance for bright path filter and calculate and store a 1 by 1 pixel render target. Okay, so if we go down to our function, as you can see, all of our thing are pretty much the same until we reach the render target, where we are rendering more render target than usual. For example, we're rendering color render as well as bilinear, which is as you can see here, we do one quarter and then we do it again to do 1/16. What that does is if we go down, so this is our color render, and if we go down even more, as you can see it so the diameter was 452 by 306. Then we quartered that to become 113 to 786, and then 116 that to 28 to 29. Our bright path filter, uh, if I go down here, as you can see, like, it's all blurry and all that. The luminance is what will shine out. The quasi render target, we have the three of them. So as they keep going down, they get blurrier and blurrier. Okay, now if we go down and we have tone mapping as well, we have the usual lighting, color, input, output. We have the same vertex shader. We have the right pixel shader. And in our path one, we again have a generate light shader, which will take the texture and light up the scene. So in our path, our bilinear, these are two function combined to one, where we scale down. We take it our 5-point star kernel as we saw before. So north, south, east, and west, and then the center is or minus the center. Uh, so in the bilinear scale down shader, we generate a pixel offset and take for a rendering, and then sum of all the surrounding color value. Uh, we are given this give us the average color of pixel with 4 around it, and then output the average. So as you can see here, we have the color depth, pixel offset, and color, which become the color depth of RGB. We enter into a for loop which is equal to the tap size, which it was 4. We add up the we sum up the pixel, the scene texture, which is the texture that I used, and the pixel offset, and then afterward we divide the color by the number of tap side plus 1, the 1 being the center, and then output the 2 color. So that was, if we go back here, sort of like those there. So that was the bilinear. In the path 2, we have the luminate 1 by 1, which read in color, luminance, etc. We loop in a for loop to get the average luminance, and then we divide it by the small screen dimension, which is this here, x value, and then we return a float for of average, 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 and then at the end is 1 for alpha. In pass 3, we give the user some function that they can use. So luminance and threshold, use adapted luminance. In the bright path shader, we read in the scene and pixel texture and then enter into an if statement. So if there it equals a full, then if the luminance is less than the threshold, then showcase a red color. If not, showcase the black color, which will showcase the normal color. Else, if the luminance is sorry, they were both greater than the 1 by 1, then showcase the red color, or else showcase the normal color, and then output the color. Pass 4, 5, and 6 are pretty much the same. To deal with the 3 quasi that I showed you down there. The quasi strength, so quasi bloom shader is sample the top, the left, top left, top right, top bottom right, top, and left, and then average them out, and then make the texture more blurry, as I show you down here. As I keep going on. Past 7 was the tone mapping. Again, we added some more function for the user, so exposure to gamma, the vignette strength, and texture lerp. So tone mapping, reading the scene in pixel, square the distance from origin, apply a simple exposure, and then apply a gamma, and then return the color. In pass 8, it's a simple back buffer. So down here we have all our passes, and now I'm going to showcase some of the functionality. So if we go up to here, as you can see, like if it's using the adapter thing, it should not like change color. But if we do this, it should. If we rotate, as you can see, like depending on where you are, the light will shine. So if we do this, as you can see, like it's not really doing the same thing. We can change the exposure, so that would increase the brightness. Then gamma, which will darken areas that are not shining. Okay, now I shall move on to the glow bloom. In the glow bloom is pretty much the same as adapted bloom, but a few minor detail. So in our if I go down here, in our linear, we need to scale down both the scene texture as well as the glow map, and then pack the color to luminance to the alpha channel. The reason is to allow the usage of any texture which contain color. So as if you look down here in color, one is showcases color. For the luminance, we use the glow map rather than for the alpha channel. So I pass the glow texture and read in the color and glow map. I enter into an if statement to check if the image, the threshold, if it's less than the threshold of the image. If it's more, then the alpha channel will glow, and then if the glow map is black, then return black. The quasi bloom shader is pretty much the same as in the other one. We pretty much have all the same function bar the adapted lumions. In tone mapping, the texture color is added to the blur glow map multiplied by the glow level, and then alert between the blur level, the blur color and the original. Pretty much everything is the same, bar that I go up to 7 rather than 8. So now if we go over here and, for example, lerp between the blur one and the glow one, as you can see, this is the blurry one, and then this is the glowy one. If we it pretty much have the same function, so exposure, brighten it up, figuring in level with like darken area, and then glow is for the glowing of the map. I'll show you the glow map that I use. Uh, so for the glow map, I have a simple one big ball and then two little ball. They didn't really fit onto the map properly. So overall, over the two bloom filters, I did all of the action needed. So the bilinear filter, the bright path filter, the quasi one by one, and then the tone mapping and then back buffer for both of them. And over, so I would like to thank you all for listening. My name was Cormac Matthews, and thank you.